This week we are talking about bathymetry, literally how deep things on the ocean floor are. This is a beautiful bathymetric map of, well, maybe you can guess. This is Palos Verdes. This is Rat Beach. This is Santa Monica and Malibu. This is Pasadena. You guessed it, this is your home, the Santa Monica Bay. Notice this deep canyon here. It's called the Redondo Canyon. It's an underwater canyon. Seafloor mapping helps us determine bathymetry, how deep things are below the sea surface. Where are the canyons? Where are the mountains? This image here shows us a trench, the Puerto Rico Trench. This is a bathymetric map, and the colors represent various depths. This week's labs won't use color maps. They will use bathymetric contours, and I have created another PowerPoint that will help explain those for you. How does seafloor mapping happen? Well, it turns out there are 4 different methods, and they all start with the letter S, the 4 S's: soundings, sonar, seismic reflection, and satellite mapping. A sounding has nothing to do with sound. It is a word that refers to measuring the depth of water with a rope. It's very, very old because people have had ropes a long time. It's low tech, and it's very effective. You just lower a rock tied to a rope until it hits the bottom, pull it up, measure the wet part of your rope, and you know how deep the water is. Sonar. This does use sound. This is a lot like how a bat flying around finds that mosquito it's going to eat. And this, in this case, of course, we have machines that emit a sound, and the sound travels through water, bounces back up. Because we know the speed of sound in water, we can time it, and that will provide us with an idea of how deep everything is. This is a multi-beam sonar. Somebody is towing something behind this boat, and the sound itself is creating an image. Single band sonar is the first one that was invented. It used echoes. If you've ever seen an old black and white movie that had men on a submarine and the submarine was making ping, ping, ping noises, those were single band sonar signals. They were accurate enough to use in battle, but compared to today, they seem kind of primitive. This was used during World War II, and it was invented long before that. And here are some men taking depth measurements using single band sonar. Multi-band sonar gives a more detailed image. It's very precise. And it's not just the area beneath the boat that is mapped. It's anything that the sound can reach. This uses a really high frequency sound, and resolution to 1 meter means this is extremely accurate. You might notice here that the image has a drill pipe. This is something that is used in industry to locate resources under the ocean and within the ocean floor. There are economic uses to all of these things, and we'll talk about economic oceanography later in the semester. This is an image created by a multi-beam echo sounder. A side scan sonar is towed behind ships. It's on a rope, and it creates very accurate maps, but they're just stripes of maps. It doesn't map the whole ocean. But this is extremely accurate. So this is a bridge that collapsed and fell to the bottom of a river, and the image was made by sound. Very precise, accurate to 1 meter. Seismic profiling. You might be familiar with the word seismic because you grew up, or at least you live now, in earthquake country. Seismic means earthquakes. Sometimes an earthquake naturally occurs, which gives us a little image of the Earth's interior when we analyze those waves on a computer. But we can replicate an earthquake. We can make a fake earthquake using dynamite, and then the energy travels through the mud, comes back at different angles and different speeds, and a computer can process that into making a very accurate image, like this one. This one actually shows where there is some oil. So if somebody were working for Chevron, this map would tell them where they can collect something valuable. The most accurate of all is satellite sea surface mapping. So this means that to learn more about our planet, we have to leave it. We have to send something into space, into orbit, and the pictures that are taken from the satellite actually determine what's on the ocean floor. It's pretty interesting. It actually is only measuring the sea surface. Wherever there is a mountain, mountains have mass, and mass increases gravity. So the sea surface is actually microscopically pulled down over mountains, and it's higher over flat areas, and even higher still over canyons. Now, you and I couldn't detect this in a boat, but a satellite can take these micro measurements and micro differences and generate a map that looks like this. This is a satellite map. It shows all of these beautiful mountains and underwater volcanoes and deep, deep canyons, and it was made from space, from orbit. Now you are ready to learn some map skills in another PowerPoint that will help you complete this week's lab.